Hey guys, welcome back to our empirical rule in R. In our previous video, we did the computation and actually drew the distribution showing the 3 sigma rule, that is 68, 95, and 97. So I want us to implement what we did in R. Actually, we are doing empirical rule in R, which is also called 68, 95, 99.7% rule, or 3 sigma rule. So consider a normal density curve. In this case, the curve will fall within 1, 2, and 3 standard deviations of the mean, as per the definition of empirical rule. Empirical rule requires one to define mean, mu, and standard deviation. So we'll be defining our mean and standard deviation. So allow me to do the code writing. Just want to clear to make sure that in my environment we do not have noises. So I run this code. So what we need to do is to get 68%. Next we'll get 95%, and lastly we'll do 99.7%. 99.7%. So to start with, we will define the mean and our standard deviation, but I will use the default mean as per R, that is mean is equals to 0 and standard deviation of 1, and I will define the steps for mean with 3 on both sides. So we want to start our code by defining a sequence of numbers from -3 to 3 and have observations 200, from which we were going to have a denom function to calculate the PDF of the normal distribution. So here we go. So we define a sequence. This one will be the first standard deviation. So defining a sequence from, so how we define sequence, we start with from. So I want to start from -3 to 3 and have a length of the observations be 200. Next, I want to define the PDF as the probability density function of the normal distribution using the function dnorm. Using the function dnorm. So dnorm, well, so for what I've defined here, so that is x stud 1. Remember, when we are defining the dnorm, the syntax is the variable of interest, then the mean and standard deviation. But by default, our mean here will be equal to 0 and standard deviation is equals to 1. That is the default. So if I omit them here, R will just take mean to be 0 and standard deviation 0. Good. So I want to have a plot. Of this to the sequence of the numbers and the PDF. So I std1. So just running these single lines to confirm that there are no errors. That's true, no error. Well, I run the second. You can confirm no error. Then third, which is a plot, and this is the plot we are having here. Oh, but I would want to change the plot type so that I have a line. So I will just add type is equals to L. That one will give me a line. So good, that's nice. So zooming this, so I have a normal distributed curve. So what we need to do with this is we are doing 68%. We will define the range from -1 to +1, and we're going to shade that region. We mean if you're given this, so we need to mark this region from -1 to +1 and extend this line to touch this curve that we define 68%. Good. So x sub 1. So creating the sequence the same from -1 to +1. I want to define the length is equals to 100. The length can keep on changing. It's not a default. You can change as per your prescription. So y string can be defined as denom of this. So let me call this that. So denom of this. So just run to confirm that everything is okay. Good. So what we need to do, we need to define now a polygon. We need to define a polygon using polygon function that will help us mark our first standard deviation from the mean. So polygon, say, so we need from -1 to 1, but considering the sequences. So we need from -1, then need this sequence to +1, well, comma, see, 0 yst d1. We need this one to be 0. We have to call it 0. Well and good. So and I want to define the color. Syncol is equals to allow me to give this dark green. So I've run this. There was no error, so I can run this. But since I want to connect actually from this, allow me to run from the first line here, coming down just to confirm no errors. Then here we draw now the region that will hold our 68%. Next, we want to compute or to get the area under the shaded region. This shaded region, we want to get the area under this by using the function pnorm. So we're going to use pnorm function from 1 and to -1. So what we're going to do, it's the area on left of 1 and left of -1. So area, the shaded region. So we'll get pnorm using pnorm from 1, then we'll subtract pnorm -1. So running this code here, we're going to get this. You can see this, which is 0.682689.5, which we can represent this as 68%. Good. So let me just put this 68% somewhere inside this area by using function text. I will just identify the position where I want my 68% to appear in this area. So allow me to consider 0